I travel with a suitcase not full of clothes, just full of stuff to give away at times. So let's get started. We're going to go for about 60 minutes. We're going to basically go pretty fast and cover a lot of ground. We're going to get very technical. This is actually an advanced kind of presentation, meaning we assume you come to this presentation knowing Kubernetes already, okay? So let's do that real quick. How many people here have already put hands on Docker at least? Hands on Docker? Almost everybody, fantastic. How many people put hands on Kubernetes at this point? All right, well, about half of you, good. For the other half who haven't been hands on Kubernetes, we'll give you the 30-second, here's what Kubernetes is. But otherwise, we're going beyond that. Okay, so Kubernetes has actually been out for a long time now. It's pretty interesting, very mature. Everybody's using it. Everybody's loving it. It's deployed with all the public cloud providers, et cetera, et cetera, et cetera. And I work for Red Hat, where we bring Kubernetes on-premise for enterprise customers, and we call that OpenShift, right? So OpenShift is Red Hat's distribution of Kubernetes for on-prem and also in the public cloud. We have plenty of public cloud customers also. But at this point, Kubernetes is the de facto standard for kind of container orchestration. Even all the previous competitors, if you will, have capitulated and said, yep, we do Kubernetes too at this point, even if you come from the Cloud Foundry ecosystem or the Docker ecosystem or the Mesos ecosystem, et cetera. So what we're now showing you is what you can do beyond that. And this Istio technology, I think you'll find is pretty interesting. At least I found it pretty interesting a year ago, and we've been working on it really hard since that point. So you guys ready to get started? Okay, this is going to move pretty fast. Just keep that in mind. All right. Okay, so there's a bunch of this 1 hour presentation I'm about to give you is also a 3-hour workshop. We run it with O'Reilly Safari Live. Anybody here Safari Live customer already? Yeah, so you can find those URLs and then sign up and come hang out with me for 3 hours if you want. This slide deck is a bit.ly Istio intro. That's the link you need to get you to all the other links, okay? There's a lot of other things you're going to find in the slide deck that you're going to want. The bit.ly Istio intro gets you to the Google Doc, where you now have the sources, because I work for Red Hat, everything is open source. So the slide deck is open source too, okay? It's a Google slide deck that you can then say file, copy, and go do what you want to with. All right, let's keep going. All right, there's a lab setup, but we're not going to do the lab setup because we're only going to do the high-level presentation here, and we're not going to actually do the hands-on stuff. This is how I came up with the title for this presentation. So Enter the Service Mesh came from my childhood hero of Bruce Lee. So I'm actually old enough to have remembered Bruce Lee as a small child before he died. And I love this movie as well. So there's a lot of great movies, so I like the concept of Enter the Dragon. Anybody else a Bruce Lee fan? All right, fantastic. All right. Do you know he's actually getting some credit for having invented hip-hop? Did you guys know that? Yeah, it's amazing. All right, so no, I'm not kidding either. It's in the Wikipedia entry right now. All right, so let's talk about your journey to awesomeness. You'll see this in all my presentations, because I believe we're always on an evolutionary path. And the way I look at any new technology, whether it be the Istio service mesh technology or Kubernetes technology, is I, as a software person, a software developer, I'm not interested in learning your thing unless I feel it gives me a net new superpower. That's how I think of it. And so I really oversimplify. I tell all the people I work with all the time, it's like, Burr, look at this cool thing we invented. I say, great, what's my superpower? And you can tell they go, but it's just cool. Like, cool's not good enough. It has to be cool and useful, okay? So we're going to talk about Istio, and I believe it's really, really useful. And after I show it to you, I believe you'll think so as well. But along that evolutionary path, we got to think in terms of we got to move to DevOps. DevOps is going to have the greatest impact on how we behave and how we work and how productive we are as an organization. I have a whole hour-long presentation talking about DevOps, the principles of that, but we're not going to spend too much time on that here. You also have to think in terms of self-service, on-demand, elastic infrastructure. How many people here have to wait, when I say wait time, okay? When you know that the business has asked you for a new idea, and you're like, oh, I got an idea, I need to experiment, I need to spin up some technology on a virtual machine, and I have to wait to get that virtual machine spun up. How many people have to wait? Okay, not too many people. So the rest of you who don't wait, you just go to Amazon and click a button, right? Or you go to Azure and click a button, or Google and click a button. Anybody have on-prem private data center, click a button? Okay, a couple. Fantastic. So private cloud architecture in that model. But the whole point is, if you have to wait, you don't actually have self-service, on-demand, elastic infrastructure that is API-driven and quota-managed. You need that now. There's no reason not to have that now, because the public cloud provides all that, and private cloud is actually no longer hard. So all that's very doable. Also be thinking in terms of your automation. Not just test automation, but all your process automation, all your deployment automation. If you're feeding CDs to a CD tray, right? No good. We're over that. Remember when MSDN used to ship? We got the big block of CDs? Yeah, we're not living in that world anymore. nor are you living in a world where you have to SSH into a machine and yum install this, yum install that, init this, systemd that. That world's gone too. Now you can burn the server to the ground and rebuild it with a script of some sort, whether it be Puppet, Chef, or Ansible, or something of that nature. And even Kubernetes gives you a ton of automation for lighting up new hardware also, right? You can basically, we have a lot of customers just using the technology on straight bare metal because it's that easy, all right? Also think in terms of CI/CD. Hopefully you guys have thought about your deployment pipeline, and hopefully you've also thought about these concepts of deployment patterns, your blue-green, your canary. That's really where we're going to talk about today, because Istio is going to give you a ton of capability to the right side of this chart, okay? And at that point, you might be ready to become a Silicon Valley unicorn. I'm in Silicon Valley. Isn't that kind of cool? And here's the part that's really cool. I love the fact this pink, snarly unicorn with a rainbow mane. Does anyone know where it comes from, by the way? Where I stole the image? Oh, wow. I totally stole this. It's GitHub's unicorn. It's the 503. It's literally the image you get when they throw up a 503. So it's the GitHub unicorn. And here's the greatest thing about that. There's actually no such thing as unicorns. Yeah, they're mythical creatures. We tend to forget that, don't we? They're in our fairy tale books, but you can't find them in real life. And I've been looking around the planet. I've yet to find one. I did find a wildebeest with one horn knocked off, and that was technically a unicorn, but didn't count. All right, so this is where the world we're going to live in. This is where Kubernetes, something like OpenShift, Kubernetes, Istio really help you. That's what we're going to think about. And here's our old monolithic application. If you saw Chris Richardson's presentation, excellent presentation earlier, he talked about the fact that monolith is not an anti-pattern, right? It's actually still a very good thing. If you saw Brad's presentation earlier, he mentions the same kinds of things. I'm here to say the monolith is awesome depending on how you architect it. And if you architect it nicely, maybe you start thinking in terms of modularization, right? You start thinking about what those real components are, and you are able to change those components independent of each other because you nicely used APIs even inside the application. Use interfaces if you're a Java person. As a matter of fact, you took advantage of the fact that we knew how to use package protected and things of that nature, right? You didn't actually just reach across boundaries and steal someone else's code. Well, we know we did. So that's really the problem. But in the world we're living in now, we're trying to think about these modules, and this concept of the monolithic application starts to fade into the background, and we start sprinkling these things out across a network as microservices. And so we built a mesh, if you will, of microservices now. And it might be what you're thinking of microservices is still your old monolithic applications as baby monoliths, right, with an API in between them. So if you just think in terms of APIs, they're just different ways to wire these things together. We've been thinking about these problems forever. You guys remember the SOAP, WSDL, SOA world? Yeah, I lived that world too, okay, and we had a lot of fun in that world, and of course now it's bad. But you know, it's one of the things we have to deal with when it comes to large-scale enterprise IT. Nothing ever goes away. We still run those COBOL transactions. We still run all that C++ stuff that we ever did. We still run the RPG on the AS400. Anybody knows what I'm talking about there? We still got all that stuff, yeah, okay? So this is the world we're trying to think about now, is how do we actually link these things together in more clever ways? And of course, microservices have their own database. You're right, we heard about that. It's like, how does that happen? Well, that's really hard. And they might have multiple points of entry. How do they have APIs, things of that nature? And we have all these principles you'll see, right? They talk about the concept of being like a product, not a project. API focused, smart endpoints, dumb pipes. All these things have been talked about ad nauseum. I'm not really that focused on that part of it because it's not necessarily meaningful unless you can actually do something that's really interesting with it, all right? And what we're going to show you is what you can do that's interesting with it. So we're going to quickly show you a quick Kubernetes recap. So for those people who didn't raise your hand earlier, like you hadn't touched Kubernetes, I'll just give you the quick 30-second demonstration so you can kind of go, oh, that's what Kubernetes is. So let's see if we can get this thing started. Hit the escape key. There we go. I'm going to just run a little demo for you. All right. So I'm running my little Kubernetes cluster here. Get namespaces. So I've got this running here. Let me make this a little bit bigger. Make things a little bit easier to see. Okay. So Kubernetes, of course, is a cluster manager for basically any kind of container image. Basically what people put in there are Docker containers. That's what people like to use with this sort of thing. Though you can actually have other types of container images too. It's not just Docker containers. Though I'll just use Docker to make this easy. So I basically have all these namespaces here. I've got a bunch of pods running as well, get pods. Okay, and then you can see I got these 3 pods in the current namespace that I'm in, customer preference and recommendation. That's my 3 little microservices. But if I do say get pods -all namespaces, Helps if you type correctly. Okay, you can see I got a ton of things running here. So that's really what we're talking about. You can actually load up a lot of technology in a very small place. In this case, it is my virtual machine. I'm running 8 gigs of RAM and 3 cores because I'm running a full cloud on this laptop. So you do have to give this a fair bit of hardware, because another way to think about it is if you are a Java person like I am, I'm running 3 JVMs right now, but I've run up to 20 JVMs, all on 8080, by the way, because all that's handled for you inside this architecture. So in other words, you can bring up everybody on 8080 or 80 or whatever port that you use. You can have 15 Node.js applications or 16 Go applications or a dozen Java applications. And you can run them all in your cloud if you know what you're doing. This is a technology called Minishift. There's another thing called Minikube, but they both work the same way. You can treat them the same way. And it basically gives you a virtual machine running Kubernetes on your laptop, okay? And so that's what I'm messing around here. So you should be familiar with the concept of namespaces. And I'll just bring up the console that we have. So here are my namespaces. You can see I got a bunch of them here. Okay, some of it is actually built into the core of the technology, meaning you can kind of ignore them like the OpenShift API server. But then there's the one that is actually for my application, customer preference and recommendation. And then, of course, there's the actual one that is Istio itself. So Istio, like many things to layer on top of Kubernetes, is also deployed as containers, also deployed as pods. Now, how many people know what the trick is for a pod? Why do we call this thing a pod? Does anyone know? No one wants to hazard a guess? It's not quite its own cluster. It is a Linux container, but it can be more than one Linux container. Okay? And it can be more than one Linux container. Not Docker logo, that's what I'm going for here. Okay, more than one Linux container, and look at the image of that we associate with a Linux container. It's a whale, and a pod is a family of whales. Okay, so that's where the word pod comes from. That's why I have this silly T-shirt. So I've had random people stop me like in a bar or airport and like, oh, pods, and I'm like, yeah, you know about Kubernetes pods? And they're like, I don't even know what you just said. Okay. So the concept of the pod comes from this emblem, being a whale. It's a group of whales. Now, this is important to understand because the concept of the pod that you get by default, and this is, again, not the Kubernetes intro class, right? We're just going to give it to you real fast, is if you look at my application again, okay, so look here. Let me drill down a preference. Look what happened there. There's actually 2 containers inside my pod. So we never knew, a lot of people didn't know, you could actually have more than one container in a pod. And what we've done with Istio here is we have a sidecar container that lives alongside your container and does a lot of really cool stuff for you. So we'll talk more about that in a second. But just mentally know, my container is running in a pod. The pod is being orchestrated by Kubernetes. And the pod also has this concept of a service. So the service is extracted from the pod itself. This is an incredibly powerful concept because I can refer to the service, and the pod implementations can recycle all the time out from under that. In other words, I could have a Java version of that service, a Python version of that service, and a Node.js and a C# version of that service, and literally load balance across all of them if I wanted to, because they're separated, right? So basically, the service represents the IP address that everyone else is thinking of, the DNS entry, and everything else is virtualized behind that. So that's actually probably the most key thing to understand about Kubernetes is the separation of service from pod. My application code, which I'm listening on port 8080, but the service is also listening on 8080, but it has the link between those 2 worlds, right? Therefore, you can have any kind of implementation you want. So just to kind of show you how to deploy one of these guys, I'm going to come over here to my little Vertex application. It doesn't matter what it is, it's Spring Boot or whatever. And actually, let's do this real quick. Like we have different, in this code base, we have like customer, we have a bunch of implementations. There's a .NET implementation. In Java, there's a Camel Spring Boot microprofile. There's .NET application. There's Node.js application. It doesn't really matter. Nice thing about this technology is you can build it in any programming language that runs in a Linux container. Okay, so that's the limitation at this point. And of course, Microsoft's working so it can run anything in a Windows container. So that basically will cover the universe. Old school .NET code that only runs on Windows container. But otherwise, everything else runs on a Linux container. Okay, but I don't have any of the Windows stuff running right now. Okay, so I have these customer preference recommendations. So if you look at them, and you're familiar with Java, which is kind of my world, you can kind of see they are basically a standard Maven type project. So I have my source directory, I have my POM XML, pretty standard stuff. There's nothing unusual there. If I bring up the Java code for this little simple Vertex endpoint, okay, let's make a change to it. I'm going to just change these first four letters here, SVCC, right? That is our Silicon Valley Code Camp. And this is going to be version 2. This is my version 2 of this application. And because I already have recommendation already deployed, so I'm going to roll out version 2. I also want to update the logs for this guy here. Let's do that, v2. Okay, so I just changed the Java code, and if you're a Java person, next thing you got to do is a Maven build. And actually what I'll do is a Maven clean package, because that produces my fat jar, if you guys are familiar with the fat jar concept, right? So if I look at target here, I can say java-jar, target, recommendation. That runs it real fast, and you can see Vertex is a super lightweight, reactive toolkit for the JVM. It runs really fast, but it still runs on 8080 by default here, and I can say localhost 8080, and there's my application change. Notice a couple things too. I have that string that I just changed, but I also have the v2 that kind of lets me know, oh, this is the new version I'm rolling out. From unknown is the host name, the computer name. It doesn't know what computer name it's on right now, but that becomes very important later on. And notice I have a little instance variable here, 1, 2, 3, 4, just to show you that I'm hitting the exact same JVM, right? It's just a simple instance variable maintaining state and with a counter. And you kind of see there it's running up there in the top. Okay, now I'm going to do, so that's my Java application. I check my code in the source code repository at this point. Maybe something happens, but let's say I want to build a Docker image. So I'm going to say Docker images, grep, example. There is recommendation 1, v1, preference v1, and customer. I'm going to build recommendation v2. So Docker build -t, example, recommendation, and v2. Helps if you spell recommendation correctly. Okay, so let's go here, and you can see there's my recommendation v2. You notice the build went really fast, because I've cached all those layers already. So if you're familiar with Docker, you guys all raised your hand and said, I did Docker. This is standard stuff. Nothing weird so far. Now, here's what's cool. When I built that Docker image, I actually built it not with Docker for Mac, but using Minishift as my Docker daemon, or Minikube if you use Minikube as my Docker daemon. So my image is already in the Kubernetes VM. It's just not launched as a Kubernetes object at this point. Hopefully that makes sense. So I can even do a Docker run, -t, -it, yeah, let's do that, -p, 8080, not PO, 8080. We're map 8080 out of it, and we're going to say example, recommendation, v2, lowercase v2. All right, so Minishift IP address. So the IP of my VM is 192.168.99. So let's do this. We're going to curl against that, and that should be on port 80. And there it is. So now I'm running it actually in the VM. Okay, so that's two good checks to know. I can run the Java code straight up, and I can run as a Docker image straight up. No biggie. Now I need to actually make it a containerized pod for Kubernetes. And that actually gets a little bit tricky because you have to know that there's all these nice little YAML files. We tend to love YAML in Kubernetes land. So let me come over here. Okay. Now there's a lot of other ways to deploy your code into Kubernetes. I'm showing you the worst case scenario. Okay, I'm showing you I want to do it the most manual way. There's a lot of other tools you can use. We have the Fabricate Maven plugin. There's Jib. There's you can also use something called S2I. There's also the Heroku build packs are now coming to Kubernetes. All those different options. But we're going to show you more the manual way. Okay, just so kind of you're familiar with it. So here's my deployment, and you can kind of see what a deployment YAML looks like. Okay, so it has a name, obviously, and you can see the label matching there. The part that's kind of interesting to us, though, is the image name. That's my Docker image name. And then you're going to see my JVM options, and then you also see my liveness probe and readiness probe. So this is why I say this is not the intro to Kubernetes class. We assume you kind of feel comfortable with this already. I have an introduction to Kubernetes, too, where we walk you through those things. But if you're familiar with these concepts, this will allow you to actually get your image that we've created. And again, it doesn't matter what language you put in there, right? Go language to Python, and deploy it into Kubernetes. Now, there's one little trick that we need to do here. Yes, you have a question, sir? Yep. You don't have to update the YAML file, because the YAML file, all it does is point to the image by name. Okay? So right here, it's only referring to the Docker image in this case. So the image was created with Docker build. That's when I got that image. And then when I did my Docker run, I saw that that Docker image works correctly. Now I'm going to launch it into Kubernetes. So if we come over here, let's do this. Watch get pods. All right, let's just see our pods coming and going. And actually, so right in that middle window, what I've done is I basically show you the pods that are currently running. And then in the bottom window, I'm actually just writing a curl script that polls against that endpoint. So it's calling customer, which calls preference, which calls recommendation. And so that's what's in production right now. And what I'm going to do now is push this new change into my production runtime. Basically, a new pod will be born. But there's one thing I want to show you real quick, and that is this Istio.CTL. Let me make sure I have it in the path. OK, good. Let's do this, temp.text. And then let's go open that up real quick. What we have is this concept of Istio now that's going to basically augment our original deployment YAML. And notice it kind of looks the same, right? It basically has our recommendation v2, our liveness probe, readiness probe, no weird things there until we get to this stuff. This is new, okay? This is where the sidecar kicks in. You can see the sidecar is called Istio proxy. It's actually based on the binary of Envoy. Envoy comes from the local Lyft team. So Lyft out here basically has been running Envoy in production for many years now. And so Envoy is actually the sidecar that sits beside your business logic and does some very special things. So we're going to talk more about that in a second. But just know that the guy is happening. You can see it talks about the sidecar status here. So Istio is already just tweaking your deployment, not your code, just your deployment, the deployment configuration, so it can add this new capability. So I'm just pulling this line directly out of our tutorial, by the way. Everything I'm showing you is completely documented. All the stuff that we're going to see today is all documented out there for you. So you can give it a try yourself. But let's go ahead and run that. So I just deployed my new deployment. You can see a new pod is being spawned. And look at that 1/2 there. So it has to pass the readiness probe for both containers. There's 2 containers in that pod, my business logic container and my sidecar container. And when you see it go 2 by 2, it gets added to the load balancer at the bottom. So you can see that we now have the new thing in production. So the load balancing you get for free. The deployment is a declarative state. This is Kubernetes. You simply say, I got to get this image running in the cluster. I need one replica of that image running in the cluster, and Kubernetes takes care of the rest. If I had 45 real servers here, and I said I want 45 of those pods, all you do is say that's what you want, and the magic happens. If one of those servers dies, that's OK. It just takes that workload, and moves it to another computer. So that's the real beauty of having Kubernetes manage that kind of infrastructure for you. And you can kind of see that, all I did was simply say deploy one, and I got a new one. And that image is now off and running. And the good news is, if somebody comes up here and misbehaves, let's say I come over here now and go, oh, you know what? I'm a bad systems administrator. Delete pod. I'm going to kill that guy. All right? I'm going to just kill it. Notice it says terminating because I killed it. And all of a sudden, it spawns again. And this is actually, for people new to Kubernetes, this is very frustrating. You're like, I told it to stop. And Kubernetes is like, you didn't tell me to stop. You just told me to kill that one. So my declared state is I have to have one. I'm going to just respawn that thing, and it's going to come back to life. This becomes super important. When I teach my Intro to Kubernetes class, I talk about this because I've had several managers who are like, you understand, this is a beautiful thing. My programmers, my Java programmers, they tend to eat all the threads in the thread pool. Has anyone ever done that before? Come on, you know you have. Okay? You eat all the threads in the thread pool because you don't use a finally block correctly. Or you eat all the memory because you don't know how to use the static final words correctly in Java. And this is true of C# too, by the way. It's just a different set of syntax. It's true of most any language that has memory management and thread management. So eventually, your code eats all the memory, eats all the threads, and guess what? It locks up and stops behaving. The good news is Kubernetes shoots it in the head and starts another one for you automatically. I've talked to several managers like, this is amazing. My programmers are so bad. This is going to save me a ton of time. They just thought that was awesome. Okay? So there we go. It's off and running. We'll leave that alone, and we'll come back to it. So we'll explain a little bit now of what we were just showing you. By the way, the intro class, if you want it, it's 9 Steps Awesome, and walks you through a lot of good stuff there, including why the JVM blows up by default. All right? Now, we've been going slowly. We got to pick up the pace. Are you guys okay with that? Okay. Now, if you're in a microservice world, you have this concept of distributed computing. You have your operating system, your JVM, your runtime, your V8 if you're Node.js, right? You know, your CLR if you're a .NET person. You had the runtime, and then you had your application logic. Okay, unless you're C++ or C or Go, you know you don't have a runtime. But other worlds have a runtime, whether it be the Python runtime called CPython, V8 if you're Node, et cetera. And then you put those things out there, and you connected them via network, right? That's really the point of microservices, is because they're now connected across a network, you can now change them independently. You can have independent teams that are interacting with those code bodies, those independent two-pizza-style teams. But the problem is, it's distributed computing. And you should be familiar with the fallacies of distributed computing. It's been documented now for many, many, many years. The concept that the network is not reliable. You guys are now at this camp right now. You will find the network isn't super reliable, right? Nor is bandwidth unlimited, nor is latency zero. And if you actually fly around the planet, and I fly all over the place, you'll find that latency is never zero. You go to Singapore, it adds 2 seconds to every transaction coming back to the US, just because, okay? Just because. And therefore, if you're trying to run an application that has latency sensitivity, 2 seconds can burn you, right? It messed up one of my applications. That's how I figured it out. It wouldn't behave right anymore. So that concept, it matters a lot. And what we're trying to do is live in this world now where we have this distributed set of components. But what happens when a failure occurs inside that service mesh, inside that series of services? Is it a cascading failure? That's really what we're trying to deal with here. How do we manage not having a cascading, cataclysmic event when we have a simple service outage? How do we actually wrap that in such a way that it's not a big problem, okay? So we think about these microservice-ilities. These are the things that I've spent a ton of time on over the last several years thinking about. I got to build an application component with a great API, whether that be SOAP or WSDL if you're old school, or JSON or REST if you're new school, or if you're really new school, gRPC or something else. Okay, it doesn't really matter. You got to build that app, but then all this other stuff around it matters. I got to have a discovery mechanism. How does A find B? I got to have some form of invocation model so I can make that call correctly. I got to think about my elasticity. Does it scale out nicely? Is it scale back properly? Is it a resilient call, or does it blow up and give me a cascading fail? Is there a pipeline involved for deployment of that component? How is it authenticated and authorized? Do we log it, monitor it, trace it? And so all these things really, really matter, okay, in my mind, when it comes to actually building a series of things. The good news is there's a lot of stuff that's happened in this space over the last several years. As I mentioned, by the way, bit.ly Istio intro gets you access to all the slides. You can just pull that up on your phone, by the way. It's just a Google Doc. All right, so if you look at this history here, and we don't have a lot of time for it, but we've been thinking about how to make big monolithic projects where we had 50 people, 200 people, big old applications, if you will, smaller, more nimble, more agile, meaning we thought about continuous integration back in the days of extreme programming. We thought about how do we make teams smaller? And then we had the Agile Manifesto. How do we make teams smaller, more agile, right? How do we do those sorts of things? How do we deal with the cloud? How do we deal with DevOps? How do we think about these problems? The Fat Jar came in with Drop Wizard as an example, right? Drop Wizard came up with the Fat Jar concept. Vertex also was built in that same time frame, about a month after that. But we had Netflix moving to Amazon. And that was probably where things got interesting. When Netflix moved to Amazon in 2010, and they realized they had to rewrite their applications to be cloud native, they then open sourced the middleware that made that cloud native in the form of Hystrix, Ribbon, and Eureka. How many people here use Eureka? Only one? Anybody using Ribbon? Anybody using Hystrix? Hystrix is the most popular. Okay, so a couple of Hystrix users. Hystrix is the most popular. There's several other things in the Netflix ecosystem. But they kind of showed us what this meant to be in the form of cloud-native microservices architecture, right? They were the ones who kind of really showed us the new way. And ThoughtWorks defined this starting in 2012. You can see Docker was born in 2013. Docker was born from a 5-minute keynote presentation at a Python conference, okay? From a company that was going out of business. They're like, but we're going to open source this cool little thing. Let me show you Docker build, Docker run. And the world was set on fire, okay? And then we had Spring Boot born in 2013 and Kubernetes born in 2014. So this created the perfect storm, if you will, for this new type of way of building applications is how I like to think of it, how I like to put it. All right, Chris, you might agree with me or not agree with me, but this moment in time was when things really started to happen. ThoughtWorks officially defined the terminology and the attributes. Kubernetes, Spring Boot, Docker really made it happen, okay? All right, now if we think of our microservices capabilities that we mentioned earlier, you had to embed them in your services before. In other words, you put your Eureka, your Ribbon, your Hystrix, your Zipkin, all those libraries were in your code. That, if you go back to old Spring Boot, Spring Cloud, that's exactly what it is, okay? It's just an annotation, but now these extra jar files are part of your class path, they're part of your POM XML, and you got to carry all this weight with you. That was the Netflix architecture. That's how it was done. In the new world, though, okay, by the way, in this world, it was Java only also, right? Because it's jar files, literally jar files you're going to carry around with you. So if you think of those things right there, we modified them with OpenShift and Kubernetes. So you can see a lot of these things came out of Kubernetes already. You don't need a Eureka. You don't need a ribbon. You get load balancing and service discovery for free with a Kubernetes-based architecture. Okay? And you can see logging, pipeline monitoring kind of came out of the OpenShift ecosystem. But Istio is really where we're going to talk about here. And by the way, I think someone already asked me, why is Istio called Istio? Was that your question? So Kubernetes, by the way, means ship's pilot or helmsman. It's a Greek nautical term. Okay, Kubernetes is a Greek nautical term. When the guys at Google came up with Kubernetes, it was called 7 and 9. You guys remember the board character internally? But when they open sourced it, they gave it the name Kubernetes. And so what happens now is inside the Kubernetes ecosystem, everybody's trying to come up with Greek nautical terms for everything. Like really, you know, if you can name your new thing a nautical term, you win, right? So there's a ton of them out there now. You can just go look at the CNCF website. You'll see a ton of stuff. But Istio is sail. Just another, you know, there's one called kedge, which is a special type of anchor. Another one called jib, which of course is the, you know, another sailing vessel component. I forget which one now. Well, there's a rudder, right? But yes, anyone a selling person here? Like, you know, on sales? We're software people, right? We don't sail. Okay. But the service mesh officially defined looks like this. The concept is very simple, though. It's another piece of infrastructure that sits on top of your infrastructure. Okay? So if you're a software developer, you're like, I don't do infrastructure. I'm here to tell you, I want you thinking about infrastructure more. When I talk about DevOps, I talk about the fact that developers need to know about ops. In other words, all the code you create doesn't add any value to your business till it lands in a production. I don't care how elegant your algorithms look and how beautiful, you know, you use tabs instead of spaces or spaces instead of tabs, and your curly braces are all lined up beautifully. I don't care, okay? Until that actually solves a problem for your business in production, it's meaningless. It's meaningless to everybody, okay? And so we should be thinking in terms of how do I get to my application to production faster? And so therefore, infrastructure matters more than ever before. I need to understand that there are computers that have to run these things, even now if these are Kubernetes-managed computers. The service mesh is another piece of infrastructure that gives you some new special capabilities, some new superpowers, if you will. And on my chart there, you can kind of see we kind of said, okay, Istio augments the discovery mechanism. It certainly augments the resiliency mechanism. It augments the authentication mechanism, monitoring and tracing. Okay? It has a lot of value there. So this is the old world before Istio. This is the new world after Istio. You don't have to have that stuff as jar files anymore. You can stick it, you can basically pull it out and let the infrastructure get managed by Kubernetes and Istio, okay? So that's where that world is now. And the sidecar intercepts all network traffic, and that's an important point. So the sidecar you see there, let's see if this will work for me. The sidecar right there, that guy, that sidecar based on Envoy, it's a little C++ application, runs in its own little container. It actually has the ability to intercept all network traffic in and outbound, ingress and egress from that pod. It's manipulating IP tables to do that trick. So if you're familiar with IP tables and that Linux kind of internal thing, you'll have seen this in action before. So it's essentially hijacking the conversation with your business logic. So your business logic thinks, I'm just listening on 8080. HTTP transactions are coming in. I'm responding to them. It doesn't know that Envoy intercepted that before it got to it. And when it responds with their HTTP 200 and something else with the payload of the response, Envoy is also intercepting that part of it too. That's how the magic happens here. So it's kind of like a man-in-the-middle attack. You've hijacked your own transaction. So it's kind of cool when you think about it. But it allows you to make all those things we talked about earlier, right, in the previous chart, external to the code base now. Okay? So this is the old world. Let's call it 2018, or 2018, I should say. You got Eureka, Ribbon, Fig Server. Those were gone when you had Kubernetes and OpenShift. But now with Istio, you can basically get rid of Zipkin, by the way. Zipkin, by the way, is still appropriate, but we like Jaeger better. Jaeger comes from the Uber team. But Zool and Hystrix also go away because of Istio. All right? And the cool part about it is, the part that really matters most, is it's no longer a Java game for this stuff. It was only Java for years. All right? That was really the point of that chart I had earlier. Now everybody can play. in this microservices architecture. Anybody here not Java? Okay, fantastic. See, all you folks can now play in this non-Java world that we have. Okay, and here's the part that's funny, though. If you were not Java, you still did it anyway, you just cheated. Okay, but I work with Node people and C people and people like that, and they were just trying to find other ways to hack around these same problems. They were trying to build their own circuit breaking technology, their own resiliency mechanisms. They were trying to build their own tracing solutions. But Envoy is that sidecar. And here's what you get when you implement it, and you already saw me deploy it. You get really intelligent polyglot routing now. And we're going to show you that in a little demonstration. You can do things like chaos engineering. So if you guys are familiar with the concept of chaos monkey from Netflix, right? The concept that they can injure themselves, right, kind of thing, by basically shooting services around their network in the head. You can basically put network faults into your application stack using Istio. So what you want is, if I have a service over here calling a service over here, I want to see if this service who's calling me is really resilient. I'll just throw up a couple errors every now and then, and just to see what happens. Does it properly receive the error, try catch exceptions, and make a return call to see if you can get a clean response back from that service? You'll find that most programmers have never done that. They get the error, and they probably just throw it back to their user, okay? But in a distributed architecture, you have to start thinking about these kinds of things, because stuff doesn't always respond on time. As a matter of fact, one of the other things you can do with the chaos capability in Istio is you can put a network slowdown in. So we've documented that as well. So that is actually more insidious than a network fault. Most of us can figure out, okay, we got a 500 back from that call, right? We got a fault back from that call, whether it be the JDBC driver with Oracle or whatever it might have been. I can deal with a fault. But what if that thing is just slow? That causes all kinds of havoc in distributed architecture, because now if you're waiting on it, and somebody's waiting on you, and somebody's waiting on them, you have this composite now set of slowness that gets all the way rolled back at some point to a user. And if you have an SLA, service level agreement you must meet, contractual agreement, you're going to have a big problem there, okay? So that concept of chaos injection is actually super cool. You also have the observability and the circuit breaking. So let's just show you this real quick. I have the, you saw me run this earlier. Let's run my little puller again. So I'm just load balancing back and forth between version 1 and version 2 of recommendation. Customer and preference all have one. You can see there's 4 total pods. So there's 1 JVM running customer, 1 JVM running preference, 2 JVMs running the version 1 here and version 2. But I get observability for free. So I mentioned earlier, we got all these guys running here. But let's just look at my Grafana, okay? So this is one of the things that's got coming out of the box is I can kind of look at the performance characteristics of these different endpoints. You can kind of see the data's coming in here, kind of slowly. And let's go here. There we go. And make sure that I have this thing still alive. So we can kind of see the performance characteristics of it. I can also look at the tracing as well. Let me go do that. So here's what the tracing looks like. Customer calls preference, preference calls recommendation. I can see the relative times associated with those things. And there's another project we've been working on called Kiali, which also shows you that I have customer preference and recommendation, but it even shows you the network traffic animation. Let's see if that'll work for me. So you can kind of see that we have traffic going to both destinations, right, V1 and V2. And so this is a new service graph we've been working on top of the service graph that was already part of Istio. But the concept here is that we have insight now into what was happening within our architecture. And you get that now for free because you've installed Istio. Because it's intercepting all the network traffic between all your components. It knows how long it takes to get from A to B and B to C. It knows exactly who called whom, right? And the cool part is you can throw those faults in that I mentioned. You can also lock things down with ACLs, right, access control list. That might be important. If you work in a large organization, and we work with some very large companies, they actually don't want a service team even able to call another service team sometimes. All right? So they want to lock the door on their service. And they don't want to do it through typical API governance, API management. They just want to lock it down at the network level, and you can do that here too. So there's all kinds of neat things you can do once you have control of that network interaction across those different services. And that's really what's happening here. So let's see, I'm going to go back to my Grafana. There it goes. Okay. If you have 500 responses, you'll see the errors showing up there. And if you run all our labs, you'll see exactly what all these things can do. We don't have a lot of time for it today, but let's kind of get here and mess around a little bit more. Okay. One thing I'll do real quick. Let's do this here up here. watch kubectl get pods. I'll just move that line up there so we have the pod count up top. I'm just going to mess around with this a little bit more. Istio, scripts Istio. I have a bunch of scripts to make this a little bit easier so I don't, have to think about all the typing of it. All right, so what we're going to do here is actually change the replica count. We're going to call kubectl, kube control scale replicas equal 2 of that specific version 2 deployment. Notice that a new v2 pod was born. That new v2 pod is of 1 and 2 right now. Watch that one, because as soon as it comes to life, 2 of 2, you'll see it being added down below. Okay? So the nice thing is the declarative state now is I need 2 of that pod, 2 of that specific image. And you can see what's happening. I have 1 of version 1 and 2 of version 2 now. And so I'm just getting nice, clean, round-robin load balancing. So this is straight Kubernetes, by the way. This is all just what you get for free with Kubernetes. And so I can just watch that thing all day. But that's not really where it gets interesting, okay? Let me call this one now. We'll scale that back. And you can see now it's terminating that one. It's going away. And notice also, you see this name right here at the end? The W8NXX, that is the server name, the host name. From a Java or Node.js or C# standpoint, that's the computer name. It doesn't know that this is a pod running in a orchestrated Kubernetes cluster running in my VM. It thinks that's the host name, the computer name. And you can kind of see right there, I also display it down here, okay? So not that one, that one. That's the name of the host that's on, okay? But what's cool about this is you can kind of then get kind of crazy with it. So let's go here. I want everybody to be on version 1. So this is where Istio really starts to shine. I'm going to use Istio create, and we'll look at this YAML in a second. Okay? I want everybody to be on version 1. Do you guys see how that works right there? So this is where your deployment cycles really can start to change. In other words, I wanted to be able to deploy like every day. Okay? Not every month or every 3 months like we have historically done. I want to deploy every day. Well, how do I deploy every day without disrupting my end users? How do I deploy every day at 10 a.m.? Okay? Gone are the days when we should be deploying on Friday night and taking all weekend. Now I want to deploy every day at 10 a.m. How do I do that? So this is where this kind of deployment architecture really helps you. Did you have a question in the back there? The same what service? Yes, the same API. So that's one key thing to any kind of microservices architecture where you want to go fast. Backward compatibility of the API matters a lot. Okay, you never break backward compatibility of your API ever if you can help it. If you remember the microservices principles, one of the key bullets there was products, not projects. You start thinking like a SaaS provider of a product, and therefore you do not want to upset your customers by breaking backward compatibility of an API. You version your API and have a new API if you have to do that, right? Yes, sir? Oh, so what, you're asking about 1 versus 2? Oh, we'll get to more detailed ways to route the traffic, okay? So this is just the simplest way is I just want the label associated with that pod to be my logic for routing the traffic. But it's a label on a pod. So anything you can apply, you can basically say room equal kitchen, and I only want kitchens to be the thing that is being routed to right now. You can get as creative as you want, but we'll show you some more sophisticated things in a second. Let me check my monitors here. I want to see how things are going. Let's see, I'm curious. Okay, our animation shows everybody's going to version 1 now. That's awesome. See the green line and the little dots there? This is very new tech right here, by the way, so I'm most curious to see how it works. All right, we'll leave that running. We'll jump back into the slide mode, though, and get you back over here. Am I moving too fast yet? Okay. I'm trying to keep you awake. It's after lunch. You got a belly full of pizza now. You know, we got to keep it going. All right, so this is how Istio is architected. The concept of your pod, running your application, your container, your JVM, that service, you know, that customer preference recommendation you saw, it has the Envoy sidecar sitting right there beside it, okay? The Envoy sidecar can speak HTTP 1.1, HTTP 2, gRPC, and TCP with TLS. If you have a protocol that you don't see there that you really, really want, let whomever know, because Envoy is pluggable. So for instance, we're working on AMQP. If you're familiar with AMQP-based message brokers, we're working on something in that category. And also there's multiple people working on a Kafka-based one too. So Kafka, the protocol. So if you have a protocol you particularly like that's not on this list, let people know and they might be working on that for you, or you can actually contribute that yourself. It's all open source. That's kind of the cool thing about this. Okay, but so those Envoy, the Envoy filters are basically allowing that traffic to come into Envoy and basically going out of Envoy and connecting all the dots. In this case, I'm just using HTTP, but you could use gRPC, or you could use TCP, right, if you really wanted to. The control plane is the next piece that really matters here. So the control plane, you can kind of see right here, is this concept of Istio, pilot, mixer, and what's now called Citadel. It was called CA. They changed the name of these things a fair bit, so you have to kind of watch out for that. So depending on, if you grab the book that I mentioned earlier, it's dated now, right? Because as soon as you put anything on paper, it's now old. So it was called CA, it's now called Citadel. So the Citadel is basically your certificate authority, because one of the things that a lot of people really like about Istio, it allows you to put TLS between all your services. Okay, and you really want encryption between all your services, even if it's all in your cluster, all on your data center. It is possible to have what's called a stretch cluster for Kubernetes, though. A lot of people do run it that way, meaning two data centers in a single cluster, in which case maybe that TLS matters even more in that case. But if you're dealing in a single data center, maybe the TLS really matters to you or not. But you also have this concept of mixer and pilot. So that's really the part we're really showing you in this set of tutorials and demos I have here. Pilot is basically the person with my rules, okay? I want to basically route this way, that way, or that way. That's my rule set. I basically create that rule set. I shoot it over to Pilot. Pilot then sends it out to the different envoys. So Pilot is kind of that fleet manager, if you will. It's responsible for setting up that routing table, and it translates it to the Envoy speak. Because you can actually go to Envoy directly, by the way, and manipulate it there directly. Or you can basically just let Pilot push that out. Mixer is our aggregator of all the telemetry data by default. So the reason we got all that telemetry information you saw earlier, like the tracing information, like the metric information, it's basically grabbing that data, shipping it out to Prometheus, right? And Prometheus lets Grafana look at it. Is kind of the idea there. And so that's one of its big wins is telemetry, but also it has quota management and rate limiting and ACL support there at that level too. In other words, you can have rules that say this endpoint is limited to 2 transactions per second. And you might not think that matters, but if you have a bunch of old C code laying around that you want to containerize, you might actually have a couple things. One, a bunch of old C code that its API is a file write and a file read. Okay, I've seen a lot of that over the years. In other words, there's no RESTful API to talk to that component. It literally is write a file, run the process, write another file, read the file, right? Does anyone have anything like that? Because certainly someone has seen some of that in your current architecture. I guarantee you have it someplace. But that might be an example where you need to rate limit that component. It cannot operate that fast. If you got to talk to a mainframe or something, right? They don't go that fast. You're guaranteed a 1 second latency just to talk to a mainframe transaction kind of thing. So you can rate limit it there also. So there's just a lot of cool things you can do at that level. Let's go ahead and fly through these charts, and we'll get back into demo mode. So your blue-green deployment. Does anyone do a blue-green deployment, by the way, by show of hands? Okay, one gentleman here, he's blue-green. But the concept of blue-green is very simple. You have your build that goes into your source code repository. It moves to your pipeline. And you notice my router, my load balancer is pointing to blue. This is going to land on green, okay? And the router pops to green. So basically, we have blue and green in production, but all our users are now pointing at green. So what I showed you earlier was essentially a blue-green deployment. I had 1 and 2, version 1 and version 2 in production, if you will, and I just flipped the bit that says, nope, everybody goes to 1. And I can flip the bit where everybody goes back to 2, or 1, or 2, or 1, or 2. That's kind of the concept of blue or green. You do have to have double the capacity for your production runtime, right? Because if blue takes a gigabyte of RAM, green has to have its own gigabyte of RAM, okay? So you have to have double the capacity in that case. But the good news is if anything fails, you just pop back to the other one, right? If green fails for some reason, something goes weird, just go back to the old one, and users don't even notice. That's kind of the idea. Then you have the concept of the canary deployment. This has got to be more sophisticated. Hopefully you've heard of the concept of canary, the canary in the coal mine. The concept of coal miners would take this canary down, a little bird, down into the coal mine, and the bird was much more sensitive to poisonous gases than the human. So the idea was the canary is a nice bird, it sings, it gives you some color down to that ugly old coal mine, and who doesn't like animals? But if it fell off its perch dead, you knew to get the hell out of the coal mine. It was the early warning indicator that bad stuff was happening, okay? So you'll hear that phrase a lot. Same kind of concept applies from a deployment pattern perspective. I can roll that thing out to production, a nice small build. I land it in production, but it only gets a subset of my users. Blue-green is all my users blue or all my users green. Canary is a subset of users, subset of transactions go to the new build, the new version. And then, if all goes well, it grows over time to take over my entire user base. And this is where it gets really, really interesting. If you are trying to do I want to deploy every Thursday at 10 a.m., and that's this team, and I want this team deploys every Tuesday at 10 a.m., you got to start thinking about these kind of advanced deployment techniques, because this allows you to roll things out in the middle of the day, and if things go bad, you can kind of just pull it back, okay? You can just go back. It's not hard to go back, and then roll it out, okay? In Kubernetes, by default, if you have 2 pods, you have a 50-50 load balancing scenario. And what I just showed you in the demo earlier was if you have 3 pods, you have a 33, 33, 34. You know, one third. The concept of Kubernetes is very straightforward. It's just round-robin load balancing you kind of get for free out of the box. With Istio now, though, you can take 2 pods and split it in a 90-10 kind of way. So this is where it gets more interesting, right? Istio allows you to be more fine-grained about that. All right. This, by the way, the Bitly Istio tutorial, everything I'm showing you and everything I talked about is fully documented. Like we have a big old book, if you will, written that's on GitHub. The physical copy of the book I was handing out earlier is a physical copy, but the one that's more upstream is the one we are keeping updated all the time. And we're going to go back, Christian and I, and get the book updated when we get a chance to. But here's the Istio tutorial. Here's what it looks like. Where is it here? All right, here. So what we've done is we've already set things up. We deployed our microservices. We showed you monitoring and tracing. Okay, we created the recommendation v2. Okay, now we're going to have some fun with it. Okay, so that's really where we're at now. So let's go back over here. You can see I'm still on version 1. No big deal there. Version 1 is running away. And actually, let's do this real quick. Okay. With version, what we did when we said everybody go to version 1, we did this. Here we go. You had this object called a destination rule. So this is a new thing. Again, if you're familiar with Kubernetes, you have all these things called kinds, objects, if you will, object types. So you have a deployment, you have a service, you have a pod, you have a replica set. All that's part of the typical Kubernetes architecture. Now with Istio, or any new thing that builds on top of Kubernetes, you have this concept called a CRD, Custom Resource Definition. It allows you as a person, as an extender of the platform, to declare your own object type. And because you've declared your own object type, all you have to do is do CRUD operations against it, meaning create it, read it, update it, delete it, of the object type. But then there's a specialized controller that looks for those events that does something with that new object type. And in the case of Istio, it adds destination rule, and it adds a virtual service. Okay? So you can kind of see in our virtual service here, 100% goes to version 1, and the destination rule says 1 or 2, right? That's what it's doing. It's saying you can go to 1 or 2, and if you apply this virtual service to it, 100% goes to virtual v1. So it's just a simple set of YAML that declares the rules of how you want your routes to work. So I have it right now set for that 100% v1. That's what's happening down here. If I go here, and I can say I want 25% of my users, or 25% of my transactions to go to v2. If you look at this one where it says 75-25 there, let's go here. That's this one right here. See, it says 75-25. It's very straightforward. It's just the declarative thing that you want. So I need 25% of my transactions going to v2. And you can see there's a couple rolling by there. You notice also, though, it's no longer even round robin like we had. By default, Istio assumes random load balancing, not even round robin load balancing. So in other words, it's randomly inserting 25% of transactions going to version 2. And so you'll see a bunch of 2s there, but then you'll see a bunch of 1s, and you'll see them kind of scattered in and on. It should be about 25%. And so if your canary rollout is, I want to roll it out to 25% of my users, I can. Okay? And we just did. Let's see here. And I still have those pods running right there. Let's do this. Again, I had this kind of scripted. Let's go back to version 1. So I'm going to flip the bit so everybody's back to v1. So that's what we did there. So you can see it's all version 1 now. And let's do this. I'm going to say for version 2, because version 2 is still running. Let's make this a little bit bigger. Make it a little bit easier to see here. Come on, bigger, bigger, bigger. There we go. There we go. So you can see version 2 is still running right here. I basically said version 2 is Safari only. If we look at that rule, where's that rule at? This one right here. It basically is using the header, HTTP header, and basically saying, if Safari is an HTTP header, I want to basically route that user to a different location. Okay? So you can see over here we still have v1, v2. See, get routes. Okay, there's my route. This is the public load balance route that's external. Let's go to Firefox over here. Let's go to my Firefox, bring it up. Okay, Firefox looks like it's all version 1. See that? No big deal there. And let's go to Safari and open that one up. And you'll see that it's all v2. Okay? This regular curl command, of course, doesn't have the HTTP header set. It's neither Safari nor Firefox, right? So in other words, everybody goes to Safari, or so everybody goes to version 1 unless they explicitly carry that token in their header that says they are Safari, in which case they go to v2. Now what I just showed you is actually very important. The fact that this thing can look at all your HTTP inbound traffic and make decisions based on that. So I think this is getting to the question you're asking. You can write rules, regex rules like you see here, based on whatever your header payload is. And therefore, you can make decisions based on that with these rules. This means you might have, for instance, I've talked to people who have really sophisticated canary deployment models. For instance, they want to deploy every day at 10 a.m. Okay, like they want to go super fast, and they want to deploy in the middle of the day. They don't want to spend all night, all weekend doing a deployment. So what they do is they roll out the new production deployment to only employees. Because employees all have to be logged into the system, therefore they have to have a login. They just set a cookie that says they're employee, and then boom, only the employees see the new version. And then they roll it out to only beta testers, beta customers, who check I'm logged in, I'm beta tested. Then it might be only logged in users. And then it might be all users, logged in or otherwise. So that concept allows you to really do some really powerful concepts when it comes to this sort of thing. So this ability to roll out just to a small group of users is very powerful. Like you guys know, one strategy, especially here in Silicon Valley, is you roll out to not the United States, but you roll out to Canada. You're in the right time zone, but you only screw up a small percentage of your user base if you break things. And that's really the concept here, is this concept is testing in production. That's really what it's all about. Because nothing is like production. Have you guys noticed that over the years? Production is always unique. No one ever spends enough money to duplicate the production data center in a dev data center, right? No one ever spends that kind of money. So production is always unique, so let's roll to production as quickly as possible, run a small bit of transactions through it, and decide if it's behaving correctly or not, okay? And as a matter of fact, it gets a little bit more sophisticated than what I just showed you. Let's go here. Okay, yeah, so we're going to remove that canary deployment. So we're going to go back to 1 and 2. Okay, so I just removed the Istio rules, and therefore we're back to default Kubernetes behavior now, 1 and 2. Okay, but let's do this. I'm going to now say I want to use a dark launch mechanism. Now, what's happening here, the dark launch says, I want to send all my users back to v1, version 1 of that pod, but notice my logging up there. It's logging 1 and 2. All transactions coming in are being sent to both, but only one's allowed to respond. 2 cannot respond. And I actually saw an example of this with FedEx Custom Critical. Okay, so FedEx Custom Critical, you guys know FedEx is the people to deliver in 24 hours. These are the people that guarantee delivery in 1 hour. Okay, so their 24 hours is like, that's child's play. 1 hour, and it's a heart. Literally where they're managing every possible thing, including the refrigeration on the truck is breaking down, and then another refrigerated truck is reading them en route. They throw the heart into the new truck so they can make it to the hospital on time. It's a very interesting team, right? They're really hardcore. But they have that same kind of concept where because everything has to be redundant, nothing can ever go down. They have 2 of everything. They actually are running every transaction twice just to be on the safe side, and one responds and one does not. That's it. That's the only difference. And if for some reason part of the infrastructure breaks, they go to the one that's not responding and just say, you respond now. So every transaction is being run twice. And so this concept of a dark launch is kind of the same principle. Now you can monitor its behavior. You can go look at your graphs now. Okay, remember these graphs I showed you earlier? I can go look at it and see, is it healthy? Is it okay? Let's go here to my namespace. I'm going to go look at tutorial. Is it healthy? Yep, I'll give them some good health statistics there. I can look at my Grafana charts. Are my requests looking okay? non-500, I can just look at the memory consumption, the log output, and decide, yep, that thing is running okay. Let's roll it out to the users now. So this concept of a dark launch, what I call a dark canary, is very, very powerful. And again, it's something built into the architecture you have here. Okay, we're nearly out of time. What else do I have here? There's all kinds of fun stuff in here, though. Like I said, this is normally a 3-hour class I teach. So those are the basic routing principles. There's also a whole section in here for advanced routing, mirroring traffic. That's basically what we're showing you, rate limiting, how to do the fault injection. I want to throw a network delay in here. And all you're doing, if you look at the pattern, is Istio create and the new YAML file that has to be applied. All right, and that's your rules. You're always dealing with these YAML files. And then you also have egress, circuit breaking. We also have the Kali stuff. So all that's in there. Okay? The next session starts at 2:15, so we need to get out of here. But here's what I want to do. You guys have the links to this presentation, right? bit.ly Istio intros to presentation, to tutorials to tutorial. Lots of good stuff there. But do me a favor real quick. Count off from this chair. So you're 1, 2, 3. Good. 4. All right. 5. 8. Wait, you're 15. And 16. Wait, we'll start back over here. Yeah, yes, sorry. 22. All right. You said 32, right? So 33. Remember your number. Keep going. You guys just got to remember your number. $56? Is that all of us? 57, okay. 57, here's what we're going to do. Okay, I have 2 Chromebooks still to give away, and a couple, we have a couple of these books, but 2 Chromebooks, all right? So here's what we're going to do. Let's see who the first winner is. 11, who was 11? All right, you get one of the Chromebooks, and... 34. 34, fantastic. So come up and get one of these Chromebooks from me. Yeah, and make sure you grab both pieces of the power pack. There we go. Yeah, well, sorry. Yeah, there we go. And you can keep the, I take the boxes off because it's easier to get through security. And then I have some stickers if anyone wants them. If anyone wants to grab one of these books, please feel free to do so. But otherwise, we're out of time, and I'll take some questions in the hallway, I guess. Thank you.